Welcome back, everybody. We are moving on to our next lesson, which is 13.2, the unit circle part 1. We are going to split this up into 2 parts due to the fact that we're not there to help you guys out on this type of stuff. So we're hoping to kind of take it a little slower. One thing that I would definitely have with you today before we start is, of course, a bunch of paper, a multitude of colors. The first thing that I am going to do as we are continuing on with the unit circle is I am going to build yet another unit circle with the radians and the degrees. If you would like to use yours from before, you are welcome to. If you want to follow along with me as I once again try to build the unit circle. Remember, I don't really have a lot of belief in memorizing anything. It's all about finding patterns. So I'm going to build a unit circle again and kind of walk through how I would do that. I'm going to go quite quickly due to time. But again, if you are not interested in watching me do this again, just fast forward to when I'm done, and then you can get to the shorter new part of the lesson. So once again, we are going to be moving forward onto the unit circle and starting to use the unit circle in order to evaluate various trig expressions. So the first thing I'm going to do is I'm going to try to start once again, just to review, building that unit circle. We only had the angle measurements in, so we are going to have to include the ratios this time, but I'm always going to start with the angles. I'm starting with my big 4. So I am first going to start with my degrees: 0, 90, 180, 270, and then 360, once again, all the way around. The next thing I like to do is I'd like to split all those in half. So once again, I just build the same way every single time. I'm a terrible drawer. I dislike protractors. So I go like this, split everything in half. So once again, I got my 45s. So there's my 45-degree angle. I know that 45 back from 180 is 135. I know that 45 more than 180 is going to be, what, 225? And then 45 more than this is 315. And there we go. There's my 45s. I'm going to switch colors a little bit, and I'm going to do my tiny little 30s. So these are my tiny pie slices. I'm going out 1 unit. So again, I know that this is my 30-degree angle, so I've got my 30s. Now I could count 30s, of course, or I could just go 30 back from 180. There's 150. 30 more than 180, 210. And then 30 back from 360, 330. Again, I don't see why you would ever have to memorize this if you can just build it. All right, and then my last slices of pie are my 60s, so my big old slices. Those are my favorite. So my 60s are going to be here. I chose orange today for my 60s. So again, going from 0, this is going to be a 60-degree angle-ish. And then 60 back from 180 is going to give me 120. Again, I'm going to go 60 here. 180 plus 60, 240. And then I'm going 60 back here, and there's 300. There we go. So now I've got all my degrees already in there. Okay, now I'm going to go to radians. So radians, I'm going to build the same way. However, I already have my degree measurements in here. So for radians, I'll probably put a little highlighter in here first. Hope you guys are doing okay with all of this. It's a little bit strange for me. It's a little awkward teaching to an audience you can't see. I can't read your faces. I can't tell who's sleeping. Can't tell who's bored. Okay, so I'm going to fill in my radians. I'm going to start again with my big 4. So I'm going to go 0 radians. I know that halfway around is going to be pi radians. All the way around is going to be 2 pi radians. And now I'm going to make my vertical pieces. So I know that half of pi is going to be pi over 2. So I've got 1 pi over 2, 2 pi over 2. This one's going to be 3 pi over 2. Now some people have a fear of fractions, but again, if you just count, you don't have to do much fraction work. All right, I'm going my halfways here, so my 45s. So if I look, I've got pi over 2. Half of pi over 2 is going to be a fourth of a pi, or pi over 4. Also remember 45s are going to be fourths. So 1 pi over 4. Now the next ones, I usually go from my axis here. So this is a full pi, or 4 pi over 4. If I go back a slice, I've got 3 pi over 4. All right, 4 pi over 4 is a full pi. One more, 5 pi over 4. Now I'm going to my 2 pi. Okay, 2 pi is really 8 fourths. So 8 fourths, back a slice, 7 fourths. And now I've got all my 45s. Okay, I'm going to do the same thing with my 30s. Remember, 30s are a tiny slice of pie. There's your 1/6 of a pie, or pi divided by 6. I'm going over here to my tiny slice. Remember, a full pie is going to be 6/6. So if I go less a slice, I've got 5. If I go more, I've got 7. Same thing here. 2 full pies is going to be 12/6. Back a slice, 11. All right, so the very last one left to build are my thirds. So I'm going a third of a pi, so pi over 3. And now this, remember, is a full pi, so 3/3. Take away 1, 2/3. Notice I do the same thing every time. 3/3 plus 1, 4/3. And then this is 6/3 minus 1, 5/3. You will find there are certain ones that you struggle with a little bit. For some reason in my life, I have always struggled with the 60s or the thirds. If I'm gonna make a mistake, it's always on those. Go figure. Okay, I'm now done with this. Maybe you have fast forwarded through me, I'm not really sure. But this is gonna be my unit circle that I continue to build upon as we go. I'm gonna pause on this for a minute and talk through these distances or these lengths or these XY values, because right now we have all these angle measurements, but we don't know where these live in the coordinate plane. And remember, when you think back to a unit circle, we are thinking about a unit circle. The reason why we call it a unit circle is that this piece right here is going to be 1 unit in length. Well, if I go 1 unit in length in this direction, how far up in this direction is this point? Well, we're going to have to figure that out. So what we are going to do first, if you think about something like that, is you can notice that if I'm trying to figure out these values, how far up am I going? I'm making what looks like here to be some right triangles. So if I look at these right triangles, I've got a 30-degree angle here, a 45-degree angle here, and a 60-degree angle there, all with a unit length of 1. And as you can see, if you look at the symmetry here, these are all going to be rotated around this axis. And I believe you did something like that last year. We're not going to do that much this year. But let's take a moment and let's revisit these triangles here so that we can kind of figure out what's going on here. I wonder if I have space here. I think I'll just keep going right here. Okay, so the first one that I'm going to look at is going to be this little right triangle here. So I'm going to take that entire right triangle and kind of separate it out from the pack. Okay, so here's the right triangle that I'm looking at right now. I'm going to zoom in a little bit. We know for a fact that this is a 30-degree angle here. We know for a fact that this is a unit length of 1 because that is the radius of my circle, if you go back to your unit circle. And now what we have to try to figure out is, does anybody remember anything about a 30, 60, 90 right triangle? I'm guessing that you probably do. On a 30, 60, 90 right triangle, we usually begin with the short leg is going to be an X value. In order to go, certain properties hold true no matter what. In order to go from my shorter leg to my hypotenuse, I am going to double that value, or 2x. So to get from x to the hypotenuse, I double. And then the other pattern that you discovered in geometry is that to get to the long leg, it is always x times the square root of 3. Okay, so if we were going to do just a couple random problems, if this had a short length of 2, then the hypotenuse would always be 4, and then the long leg would always be 2 root 3. And you worked with special right triangles a lot last year. We're just going to use this information in order to help us. Let's do another one. Let's say, what if this short leg was 5? Well, that means that the hypotenuse would be doubled. Hypotenuse would be 10. And the long leg would have a length of 5 root 3, no matter what, in a special right triangle. And we would use our trig ratios to do those. Okay, well, for our purposes, we actually know the hypotenuse. The hypotenuse is 1. So we need to figure out that vertical distance and that horizontal distance in order to find this point in the plane. So if I go back to my triangles, we already know that this is 1. And what we are going to be looking for here is we are trying to look for the XY coordinates in that plane. So I'm trying to figure out the horizontal distance and the vertical distance to get that XY piece. So if I'm going back here, in order to go backwards, I'm going to have to divide by 2, which means that short leg is 1/2. If the hypotenuse is 1, short leg is going to be 1/2. Which means now, how do I get my long leg? Well, that's going to be 1/2 root 3, or root 3 halves, or root 3 over 2. Okay, so these pieces are going to be incredibly important as I put them onto my unit circle. So, using those properties of that special right triangle, I can now add in my XY value. So for this particular point at a 30-degree angle, I'm going to be traveling a horizontal distance of root 3 over 2 and a vertical distance of 1/2, no matter what, all the time. Okay, well, what else could I figure out now? Well, if this is my 30 degree, that means over here, my 150, it's exactly the same. However, I'm traveling left and up. So that means that my XY values are going to be negative root 3 over 2, up 1/2. For this 30-degree angle, it's going to be the same, except this time I have negative root 3 over 2 down a distance of 1/2. And if I move into the fourth quadrant, I'm going over root 3 over 2, down 1/2. So as you can see the symmetry there, moving from quadrant to quadrant, I've got my positive, negative, positive, negative, negative, positive, negative. And the same thing holds true for the other ones. Okay, so what about this 60-degree angle now? Okay, well, the 60-degree angle is just a rotated 30-degree angle. So here I've got my 60, which means my short distance, my X value that I travel, there's your 1/2. So on my 60s, I travel 1/2. And then the long distance that I travel vertically is my root 3 over 2. This is going to be your same triangle, just flipped around. So the same thing here. Here's another 60 degree, except I'm going to go left only a short distance, up a long distance. So I'm going to go left 1/2, up root 3 over 2. All right, find another 60. Here we go. This one I'm going left and down, and I'm in the third quadrant. So I'm going left my short distance, down my long distance. Again, where are these numbers coming from? They're coming from that special right triangle. If you have a radius of 1, Your short distance is going to be 1/2, and your long distance is going to be root 3 over 2. All right, this last one. This time I would be traveling from the origin, short distance, down my long distance. So I'm going to go right 1/2, down root 3 over 2. So you can see the symmetry there between your 30s and your 60s, or your pi over 6s and your pi over 3s. Okay, well, now we have to deal with this 45, 90 right triangle. So again, I'm going to take this right triangle out of the unit circle. I'm going to enlarge it a little bit down here. And let's try to remember the properties of a 45, 90 right triangle. All right, so if this angle is 45, this angle is also 45. Okay, well, what do you remember about this? Well, we know whatever this leg is, let's say it's 7, then we also know, based on the fact that this is an isosceles triangle, if base angles are the same, then this is an isosceles triangle. The other leg is 7, which means my hypotenuse is going to be 7 squared plus 7 squared square rooted. And I will always end up with 7 root 2, no matter what. All right, let's try another one. If this one was 3, that means that this one is 3, and the hypotenuse will be 3 root 2. Always, no matter what. Okay, so let's go back to our triangle. What piece do we know in this triangle? Well, the piece that we know in this triangle is, unfortunately, our hypotenuse. We know our hypotenuse is a distance of 1 unit, and we're missing the legs. So we are going to need to go backwards. So all of these, you're multiplying by root 2. This time, if my hypotenuse is 1, how do I travel backwards? Well, you're going to have to divide by root 2, which is unfortunate. So I start with a unit length of 1. I'm going to divide by root 2. And once again, this is going to bother mathematicians everywhere because you know that we cannot have a radical in the denominator, which means we have to rationalize the denominator. So that is going to leave me by having to multiply by fancy form of 1. Square root of 2 over square root of 2 is our method for rationalizing the denominator, which means I end up with root 2 up top. Square root of 2 times square root of 2 is square root of 4, or square root of 2 squared. Either way, we end up undoing that irrational number in the denominator. So we end up with a side length of root 2 over 2. Well, if this side length is root 2 over 2, then this side length is also root 2 over 2. Which brings me back to my unit circle, which means that now that I know if this is a length of 1, then this is root 2 over 2, and this is root 2 over 2, which means I end up traveling a horizontal distance of root 2 over 2 and a vertical distance of root 2 over 2. And as we travel around the unit circle, this one travels left and up and left, so the negative, and down, negative. Notice everything in my third quadrant is negative. And as I get to 315, I end up with right and down. Okay. Oof, that's a full unit circle right there. However, we forgot one thing. We forgot about our big 4. I forgot about our big 4. So if I'm looking for this value at 0, I know that at 0, this travels a length of 1, that's my radius, and a vertical distance of nothing. Okay, what about pi over 2? Well, I know that this value travels a horizontal distance of nothing and a vertical distance of 1. This one over here, I know that I travel left 1, vertically nothing, and down here on my unit circle, 0, negative 1. All right, now I believe I have everything filled in for my unit circle. Okay, so Again, you can stop that. You can rewind it. This unit circle is not going to go away. And I try to warn my students every single year that this unit circle, the more that you can build this and the more patterns that you can see in this unit circle, the easier your life will be moving forward here until June. I want you to look at some patterns for a second. If you look at your X, how far these travel in the X direction, you travel furthest at first, which is 1. And then you travel root 3 over 2, root 2 over 2, 1 over 2, 0. So look for those patterns in the X. I know there's all different kinds of ways to remember this. And then it goes the inverse with your Y values. You travel nothing, and then up 1 over 2, root 2 over 2, root 3 over 2, and then you're up there at 1. So again, especially if you can just kind of get this first quadrant, the other quadrants fall into place a little bit. So this will not go away, I promise. It is going to be the basis for building trig functions as we move forward. So all of these numbers here are definitely something to take very seriously. An extension would be just build a blank unit circle. That's what I would do over and over and over again. Okay, so now let's use this unit circle a little bit. I'm going to grab a fresh sheet of paper here, and I'm going to kind of have my unit circle handy. So one thing that we want you to do tonight, I've got about 10 minutes left to go through some examples, is we are going to ask you to use this unit circle to evaluate some trig expressions without using a calculator. So number 1, what if I would like you to evaluate, please, I have to skip something for a second. I gotta go back to our triangles. What am I thinking? Okay, so one thing we need to talk about is our trig ratios. Sorry, and how they relate to the unit circle. So the first one I want to look at is I want to look at the cosine of 30 degrees for a second. So if I look at the cosine of 30 degrees, okay, so cosine of 30, I'm looking for adjacent, so root 3 over 2, divided by my hypotenuse, which is just 1. Okay, so the cosine of 30 degrees is just root 3 over 2. All right, what if I wanted to find the cosine of 60 degrees? Okay, so now I'm gonna look at 60 degrees. Adjacent, 1/2, divided by hypotenuse of 1. Cosine of 60 degrees is just 1/2. Okay, well, let's do another special angle. What about the cosine of 45 degrees? Okay, so here's my 45 degree angle. Cosine is going to be adjacent root 2 over 2 divided by a hypotenuse of 1. So I want you to look at your cosine function and the connections to the unit circle. So take a look for a second. Cosine of 30, here's your 30 degree angle, is root 3 over 2. Cosine of 30 is root 3 over 2. Cosine of 60 is 1/2. And cosine of 45 is root 2 over 2. So where are you finding all of those cosine values? All of your cosine values are showing up in the X position in your ordered pairs. Okay, well, let's see about sine. What about the sine of 30 degrees back in my triangle? Sine of 30 degrees is going to be opposite, 1/2, divided by 1. All right. Sine of 60 degrees is going to be opposite, root 3 over 2, divided by 1. And my sine of 45 degrees is going to be opposite, root 2 over 2, over 1. Okay, so let's look back at our unit circle. For sine of 30 degrees, sine of 30, there's my 30, sine is 1/2. Well, that shows up right there as my y value. All right, what about sine of 60? Sine of 60 is root 3 over 2. Well, that's my y value. Sine of 45, root 2 over 2. There's my y value again. So right now, as you can see, another thing from triangles to your unit circles is you can make the case for the fact that on your unit circle, cosine is your x value and sine is your y value. Okay, so if I'm going to my second sheet of paper here, can't believe I was going to skip that. One thing we also know about your unit circle is we know that if you are looking at your coordinate pair, x, y, we know that the horizontal distance traveled is going to be cosine at that angle. The vertical distance traveled is going to be sine at that angle. And one thing that you will also discover as you're traveling is that tangent is going to be your opposite over your adjacent always, which means tangent is going to be sine divided by cosine. Always, no matter what. So if I were you, I would definitely get out that highlighter because this is an important piece of information. Your horizontal distance will always represent your x value. Your vertical distance will always represent your y value and your sine. And tangent will always be sine divided by cosine. Okay, feel free to take a minute to pause that. So now we can finally use the unit circle. So here we go, using the unit circle in order to evaluate. Okay, so let's say that I wanted you to evaluate the sine of 3 pi over 4. Okay, well, the first thing that I would think about is okay, sine is my vertical distance or my y value. So I'm thinking about the y value at this position of 3 pi over 4. Now at first, you're gonna have to use your unit circle quite a bit. So I'm going to locate 3 pi over 4. My y value is root 2 over 2. So the sine of 3 pi over 4 is root 2 over 2. We're using exact values, no calculators. Unit circle. Let's try another one. What if I wanted the cosine of negative pi over 2? Okay, cosine of negative pi over 2. So I know for sure that I'm going backwards half a pi. And I know for sure when I see cosine, I'm thinking x value. So I'm thinking about that x value back pi over 2. So I'm looking for this value right here. Well, I'm not going right and left at all. My x value is 0. So I'm going to start trying to use this a little bit, and then I can go back to my unit circle and see that, in fact, I was correct. All right, let's try another one. Let's try tangent. All right, let's try tangent of, let me see. Looking at your homework to see if you have degrees or radians. All right, let's go tangent of, let's do kind of an easier one. How about tangent of, I don't know, 5 pi. Oh boy. All right, tangent of 5 pi. So I'm thinking about that. I know I've got 2 pi. I know I've got 4 pi. And 1 more pi leaves me here. Okay, well, I know that this value is -1, 0. And I'm thinking tangent is going to be sine over cosine, or y divided by x. So my tangent is going to be 0 divided by -1, or 0. Some of these are going to get kind of tricky, especially with tangent. All right, let's do number 4. How about we'll go cosine, I'm going to do kind of a tough one, -7 pi over 6. Okay, so tough because I'm going backwards. Also tough because that's kind of a nasty fraction. But remember, if I'm going backwards, 6 pi over 6 is a full pi. 6 pi over 6. So I just have to go another tiny little slice. So I'm looking for that tiny little slice. Okay, I can cheat. I can go back here. So my tiny little slice is right here. My cosine value is negative root 3 over 2. Awesome. Something that's going to get kind of tricky, and this is going to be my last one, and I'm going to have you struggle through your assignment a little bit, is what is going to happen when you have a trickier tangent. Let's try tangent of pi over 3. All right, my third means I'm up here, which means I'm traveling short, long. So I've got positive 1/2 root 3 over 2. I'm trying to go from memory here. And when I do tangent, I'm going to do y divided by x. So I'm going to be dividing root 3 over 2 divided by 1/2. Ugh, can't get much worse than that. All right, well, instead of dividing fractions, I'm going to multiply by the inverse. So I'm going to be multiplying by 2 over 1. Oh, well, that didn't end up being that tricky. 2's divide out. I end up with a tangent of root 3 over 1, or just root 3. Okay, that was a lot of information today, you guys. We not only built an entire unit circle, but then we rather haphazardly realized that cosine is going to be your x values, sine will end up being your y values, tangent will end up being the ratio of sine over cosine, and then using those in a lot of different ways. Your practice problems for tonight are going to be a worksheet that is linked, worksheet 13.2, but I believe you will only be doing the front side of the worksheet. Your extension problems are going to just be simply to build unit circles. There is a template listed on Planbook, or you can just get any old sheet of paper and just build like we've been doing. So good luck. Your assignment will look something like this. And we will be able to talk tomorrow in Zoom sessions because you might need it. All right, have fun. Bye.